Brilliant. So thanks very much, everybody, for joining us on our Brunch and Learn today. And we've got Paul Chapman with us, who's one of our global Red Hat Power SMEs. And he's going to talk about OpenShift Multi-Architecture clusters. So hopefully he'll explain that and what it is, and also do a demo. So over to you, Paul.
Okay, thanks very much for that, Paul. And thanks for inviting me today. Thanks for everybody joining. Appreciate your time. So this is quite a new topic, multi-architecture clusters for Power at least, and generally speaking for OpenShift. But hopefully I'll be able to take you through the basics of this, along with sharing information that you can go off and refer to or look at more detail after this event, because 25 minutes or so that we've got now, it's not very long. We could probably spend that amount of time on just the demo alone. So with that, let's just flick through. Okay, so the first thing I'd like to ask, really, I'm not sure that I should start with an ask, but I've been working with the development and research team on this product for a little while now, and I'll talk about an early adoption program, or what we call a co-creation process. And as part of that, because it is a relatively new product, although we've been working on it, I think, for 2 years now, and the same is true for Red Hat, that we're very interested in your feedback. We're very interested and keen to work with customers directly on projects, and this will help influence the product roadmap. So my ask to you is, on the link here, I think you can click on the screen or on the link below. There's a very simple 13-question survey. Most of it is multiple choice, but I would really appreciate you completing that after the session, or as we go through the session, if you like. Do you want to just do a reminder when we get to the end?
Do you want to put it in the chat, Paul? I don't think they can click on that. So.
Yeah, good point. And I did.
Yeah, so put it in the chat. Or I'll put it in the chat. I'll put it in the chat.
Brilliant.
Okay. If people want to ask questions, they can put it in the chat too.
Yeah, perfect. Okay. So then moving on, like I say, time is a bit short for the amount of information I've provided here. So rather than boring everybody, hopefully that if you're interested in certain bits, you can go off and refer to that afterwards. I'm happy to speak with anybody about any of this material after the event if you want to go into more detail. But what I thought I'd do, the demo I've actually got towards the end of this session, but just in case we time out, there's not enough time to get there, and so on and so forth. I'm going to build a multi-architecture solution and cluster using microservices. So what I'd like to do is just kick that build off now, because there's so many microservices as part of the overall solution. When you start it up for the first time, it takes 4 or 5 minutes to stabilize, because there's several open source databases in there communicating. So I thought if I kicked that off first, let me just get the command to do that. Show you. So here I use the customize command to build the manifests of each of the microservices. I piped it through an OC command, which is an OpenShift command to build that. And then we see the output of that, where it deploys all of the microservices, sets up the persistent storage, etc., etc. I then run the OC get nodes command, and these two are Power worker nodes. The next 3 are x86 control plane, and then we have 2 x86 worker nodes. Now that command doesn't show you, I mean, you're taking my word for it, but when we run it with the -o wide command, we can then see here PPC64 little Indian next to the worker 0, and the same for worker 1. So worker 0 and 1 are Power, and all the rest are x86. Then what I did was run OC get pods, which shows you each of the microservices. At that point, some of them are running. One of one means it's actually up and running, it's okay. We can see here the catalog microservice was still starting, and also the user was still starting there, so it wasn't ready Now, it may well be actually that if I run that again now, it's all running. So it is actually all up and running at this point. Still, what I'll do, I'll flash back to the presentation and come back to this in a moment. So the topics that I wanted to cover briefly, or at least give you the information. So a lot of this, you will be able to get a copy of this presentation. There's lots of clickable links that go off to publicly available PDFs or videos or whatever. Some of them I just uploaded last night. But the topics, I thought to introduce why multi-architecture compute. Well, it assumes you already know OpenShift and therefore why you would use Power with OpenShift. But I thought I'd just put in some information in there for anybody that didn't know. Then we cover what is multi-architecture compute, why use it, how to use it, introduce the early adoption program, because as I say, we're very keen, both Red Hat and IBM, to work with customers on this to influence the future roadmap, and then demos. So I've got a couple of recordings of demos and of course this live one that we can go through. So this is really about why OpenShift or why use Power with OpenShift. And here, when you have a presentation, you can download a total cost of ownership report. It's quite new because it's dated September 2023. I know that it's based on previous versions, but this comes up to date with the latest x86 Ice Lake systems. And you know, it's only 4 pages. It should be a very simple read, but it shows how Power with OpenShift can save you money and increase performance, etc. I've started working with OpenShift and Power and all this Power modernization stuff. I'm actually losing track now. I'm not sure if it was 3 or 4 years ago. I think it might be 4. But what I'm seeing, and what excited me then, was just how much more workload is available on Power today. So whether it be open source, and you can get this from Docker, you know, all the normal candidates, Docker Hub and Red Hat Catalog. We actually have a Power developer team porting open source products all the time. And that's what we did with .NET. We passed that to Red Hat so that they could productize that and provide support last November. That was .NET 7. .NET 8 has just been released by Microsoft, and I think the blog has just gone out today, or Red Hat and IBM are releasing their blogs extremely soon. There's lots more open source available, big community, and also with IBM Cloud Packs, there's so much going on there all the time. We'll cover that later on, as well as our traditional workloads. I get people contacting me about SAP HANA and connecting to application servers with .NET and stuff, and also all the Red Hat software, whether it be cloud native or runtimes, etc. So we have much more potential workloads for Power. We still have the same benefits. Flash over to the next screen. So this is a use case. So I was presenting in Las Vegas for the Tech Exchange in August, and this was one of a couple of use case sessions that I attended, Celopar. You can download this. It's a public reference. You can download it from this link, and I've just put a couple of pages on here. It's a customer presentation. They talk about their challenges, how they overcame it, and their results. But the results were in line with the TCO study we showed earlier on, with 38% reduction in license costs and 53% reduced costs due to not using VMware as we have Power VM, etc. This is something that a partner of ours in America created, and I stumbled across this a couple of weeks ago and shared it on LinkedIn. It's one of these drawing videos, and it's 3 minutes why Power on OpenShift. So I just encourage you that if you're interested or need to know more about that, then you click that link and go find it. I'm rushing through to make sure we stay on time. So then what is Mac? So I shared on LinkedIn that multi-architecture compute was available as part of OpenShift Container Platform version 4.14 a couple of weeks ago. There's a link to that here. It was very popular, lots of people resharing it, etc. For further detail, I've included a screen grab and also a link to the release notes, which you can look at. But at a high level, previously, we needed a different OpenShift cluster for each type of processor architecture. So you might need a Power 10 cluster, a Z cluster, x86, ARM, and each time you do this, you have to have different control planes, which is typically for a full production node three LPARs. So one thing is, why duplicate the administrative side with a control plane? But this makes it difficult then to do the networking. So if you've got a very complex solution that needs two architectures, or indeed if you're just going to make economical benefits by using the workload that works on Power and the other stuff on x86, then it complicates things. The other thing is that when you're using one architecture, it makes it harder to move that workload from one cluster to another. It can be done, and we have demonstrations showing it, especially using Red Hat Advanced Cluster Manager. But what we have now is the single control plane. So one cluster, and we can include all the processor architectures in there. So it truly allows you to run the workload on the best architecture for your choice. And that might change in the future.
We had a question, Paul, about does the master node have to run on x86? And I think looking at your picture there, I think a master node is a control node. And
yeah, that's right. So so that was the next thing I was going to say, actually. Today, the control plane must run on x86. It is possible to run it on other technologies. They really don't want to do it on mixed technologies, so they don't want like 3 control planes nodes and one on each architecture type thing. This is one of the things that Red Hat and IBM are seeking feedback on. We do have people saying, no, we would want to run it on Power only. Others don't really mind, but that is one of the questions, I think, in that survey. So again, just an ask if you could fill that out for us. But today, yes, the control plane is x86, and then we just simply add an LPAR, a Power worker node to that. So, yeah. So again, checking the sound. So now we have multi-architecture compute. Why would you actually want to do it? Well, I've alluded to that really on the previous slide where I said where it created some complexities. So first of all, the cost optimization. So with Z and with Power, we can consolidate a lot better. We can typically run, at least 4 times as many containers per core on Power than we can on x86. We tend to find that people grow when they start using this technology. It's a bit like we've had server sprawl, we've had virtualization, LPAR, virtual machine sprawl, and of course there's going to be container sprawl. So the ability to run many more workloads on the same system is just what Power does really well, consolidation. As part of that, and the previous TCO study will show, and our customer references, then the workloads that do run on Power, you can save an awful lot of money by doing so. The other thing is migration. So some customers may already be running in an x86 environment, and they might say, well, actually this workload would be better on Power, so we could migrate. And when it's all within the same cluster, that makes it a lot simpler to do. Another business partner we're working with, we've set up an x86 appliance along with x86 servers as long as Power, and it makes it very easy to do benchmarks on workloads, so you can see just how much better it is on one platform than another, and then you can decide on the cost basis as to where to deploy it. The other thing is with very complex solutions like Cloud Pak for Data, this might include like 50 different applications. And some might run better on Power, some might run better on x86, some might only run on x86. But a customer would, kind of want it to run within the same overall cluster. And now we can have multi-architecture compute. One of the demonstrations that's recorded later on shows how you can do some of that work on x86, then other stuff on Power, and then more on x86 again. So it makes it all easier. It's the same case with Cloud Pak for Integration and API Connect. Now, we may well get API Connect later next year. We don't have it today, but this technology allows us to run the single cluster and deploy the workload in the best place that we have today. But not only that, to move it if we want easily later on. And then of course there's a DevOps, and there's a couple of slides on that coming up now. So with the DevOps environment, we can have developers actually just developing in the first instance and then deploying into either different repositories and creating different containers, or we can actually just run it within the same cluster using the same repository and then deploying. So you can see here we're looking at before multi-architecture compute, whereby there's a lot more steps. It's more complicated for the developers. And here, where we have different processor architectures all within the same cluster, it reduces that, and it reduces time and makes it easier for the developers. We can run that as part of a code creation process, which I'll cover shortly. So this is how to actually implement multi-architecture compute. So we have the documentation here, so there's the links that you can go through to with explicit instructions on how to do it. The things I want to call out, a bit like the fact that the control plane needs to be on x86 previously, is calling out costs and subscription considerations. So multi-architecture compute, there's no additional charge for it. It's a part of OpenShift, so that's good news. However, just when you start running a cluster with multi-architectures, then x86 and ARM are part of the same Red Hat product code, and Power and Z are on different product codes. So it's not a bad thing, but you just license the worker nodes for what they are. You buy the subscriptions for x86 and ARM, and you buy them for Power. So you just need to have subscriptions for what you're using. So the early adoption program, and we haven't got long. So it's just a few weeks ago, I put a video out on LinkedIn and uploaded it to YouTube, and it's like 90 seconds, that's all. But it describes multi-architecture compute. It describes the trial, collaboration and feedback program that we're running with development, and it's inviting people to join. Now, I have a few customers doing this already. We're limited to the amount that we can do because we're actually standing up cloud environments and giving to customers to try this out. But I've certainly got customers in the UK and Italy, and we have customers that I'm aware of in America doing this too. So it's only 90 seconds. You can take a look at that and it'll describe the process. Moving on, the code creation process, the way that we've done that is run a quick meeting to describe multi-architecture compute. Then we demonstrate how it can work, and then we decide whether a customer would actually want to go on and co-create with us, moving on to the next stage. And as we move on to the next stage, we can either provide an environment with a demonstration use for customers to trial and provide feedback with us, which, as I said, we use to influence future roadmap and to improve the product, or to change the direction so it suits people's needs. Or we can actually bring a customer's environment. So there's independent software vendors I'm working with that bring in their own applications to use on the environment we provide. Or indeed, we can actually set it up for you on your own environment if you want to do that too. And the process typically lasts sort of 4 to 6 weeks or so. So I think we're not doing too bad for time actually as we go on to the demo. This is a demonstration, as I said before, of Cloud Pak for Data. And on the left-hand side here, we can see applications running on x86 worker nodes within a cluster, and then we have it running on Power in the green in the middle, and then more going on x86. This is what I've uploaded to YouTube. So you can look at that at your own time. It's 5 minutes. It's a 5-minute video and walks you through that, and it is based on the application itself. The other demonstration that I've got, and this is what I did at the beginning of today's session. This is the Sock Shop. It's an open source e-commerce solution that was designed to actually benchmark and to for developers to use to get used to microservice solutions. So we can see here we've got a front end written in Node.js. We have microservices using Java, Redis, MongoDB, Go, RabbitMQ, you know, a whole bunch there, and they all interlink to make the solution. And we've made this so that it will run on Intel or Power. And this was actually designed like 5 or 6 years ago, so before Power was available for this. But we've you know, shown how easy it is to make that work. This is a video that I uploaded last night. It's 10 minutes of I go through and build it and then show it working. But I can flash back now to that build that I did earlier on. So as I say, we could see all the microservices are working here. If I go through to our OpenShift environment, I can now see that we have a Sock Shop project. And as that loads, so this is all the different microservices that have been built. And we can click to go through and open the URL for the user front end, which is actually this. If I refresh the screen for it, then this is the application itself. We can look into the catalog. We can search all of those microservices, create users, and reuse the application. Now, I think, Paul, I'm running out of time. 3 minutes to go.
Correct.
But yeah, this is all useful, and the demo that I just put up onto YouTube last night. There's no voiceover because I just did it very quickly last night, but it'll show you logging in and using all of that. The other thing I think I can just quickly show, if I go into administrator view and we could look at the compute mode into nodes, then we can see here what I showed you on the command line earlier. Worker 0 and worker 1 are both E980s power, and all the rest is VPC, x86 servers in the cloud, 3 control planes, and 2 worker nodes. So with that, just going back to the presentation, I'll put a couple of screen grabs of that demo in. And just to say, we've got 2 minutes left. Thank you very much for your time today. It's a bit of a fast drive through that presentation, but there's lots more material that you can go through. If you want me to come back, or if you want a one-on-one session or to look into any of this in more detail, then I'm more than happy to do so. I do invite you to let us know if you would like to join us in code creation process. If you have ideas of what you would like to do with this or try it out. There is limited resources that we can do that, because we are standing up big environments to do so, and we have to get developers ready to assist. But if we don't even do it with developers, we do POCs in your own environment. And just another call out, please fill in the survey. We would appreciate your feedback on that. It's not particular feedback on my presentation here today. It is about multi-arch compute and what, you know, how you would like to use it. And then if you want to get in touch with me, you can come direct, if you know me, through Paul, or my email, website, LinkedIn, and YouTube is all there. So that must be about 1 minute to go, Paul.
That's perfect. Thanks very much, Paul. And thanks for joining today. And as I say, I will get this presentation out to everybody with a link to the recording by the end of today. So yeah, thank you very much, Paul, and thank you all for joining.
Brilliant. Take care. Enjoy the weekend. Bye now.